Okay, great. So when it comes to Techran outputs, there's a couple numbers you got to pay attention to. The first of which is well, let me just explain all of it. The first column is going to be called the date, and that's pretty self-explanatory. Oh, this is going to fall.
Sorry.
The next column is the time, which is essentially Techran time. Remember, that doesn't necessarily correspond to real time, so it's best to record both when you're running a sample. You can set the time on the Techran though if you want it to, correspond better.
Mm-hmm.
Past that, I'm sorry.
So the time corresponds to Techran's time.
Yeah,
Okay.
but you can change it.
Okay.
I just haven't bothered because it doesn't really matter to me.
Mm-hmm.
I reassign the time anyway because I'm just worried about the time intervals.
Mm-hmm.
But you can change it if it bothers you or makes your life easier later on.
Mm-hmm.
The next column after time is the type. That's generally just what mode it's been collecting in. We're always going to be running continuous and not single, meaning we're going to use both traps instead of one. However, you can set it to use one trap if you have a problem with one of the traps. So keep that in mind. The next column, titled C, is actually telling you which trap it's sampling from, either trap A or trap B. The column after that is the status. Generally, there are a couple values you can get for this column. There's the OK value, which you see on the screen now. There's the M plus value, which means you're detecting multiple peaks, which means you're flooding the system with mercury. And then there's the NP, which is no peak, which means you're not detecting anything. I'm just going to wait for the pump to subside, because it should see the carrier flow came back and started. Okay, so we were talking about the status column. So OK, M plus, and NP. M plus again means an overload of mercury. NP means you're not getting any peaks. Typically, that will refer to a problem in the system, either a leak in the system because it's leaking out and it's not detecting anything, or you have an issue with the lamp, or the cuvette's dirty so there's no light getting through, or the photomultiplier tube needs to be replaced. But we can talk about that a little later. The next column after that is called the flags. Generally, you'll see a 1, 1, 2, 2, 3, 3, 4, 4. Here you see a 0, 0, 0 because it's not hooked up to any port sampler. The port sampler is what dictates what flag you're sampling from. Remember, the flags correspond to the lines that feed into the hoods. If you remember 1, 1, 2, 2, 3, 3, 4, 4, those are lines corresponding to the inlets and outlets inside of the hood. The next column is the add time. So the add time is actually 300 seconds currently. That's the default value. That means that you're sampling for 5 minutes per trap. And you can actually change that within the Techran system itself. You can change the method and save it, depending on what you might want to use. You can change it to a shorter time or a longer time. It's just in the manual, it says 5 minutes is the most optimal, shortest time you can use. The next column after that is the volume. So, as we discussed before, it pulls 1.5 liters per minute from the actual sample, and an additional 6 liters of carrier gas. So remember, when you're calculating for flux, you're only calculating that initial 1.5 liters that you're pulling from the sample, because the extra 6 liters of carrier gas are not factored into the calculation, because they're not coming from the sample. Next to that is the baseline. The baseline value is really just telling you the baseline voltage, which again can be adjusted and is very dependent upon your lamp quality. Oh, shifted. Let me just scroll up a bit here. Typically, we like the baseline to be around 0.1. We'll give it a leeway value of 0.02, so it can go up to 0.12 or 0.08, but not much more than that. Generally, not even as low as 0.08. Past that, the next column is the baseline deviation. Generally, you want your baseline deviation to be an order of magnitude lower. Well, you don't need it to be 0.01, but you do want it to be 0.0 something. So while it can be close to 0.01, 0.06 or 0.05, 0.07 even is okay. However, when it starts to approach 0.1, you start to have problems. And again, that can pertain to problems with the lamp, or problems with the detector, or problems with the cuvette, or problems with stuff stuck in the traps. generally, stuff stuck in the traps means there's stuff stuck in the cuvette. Okay, moving past that. As far as max voltage is concerned, I'm not exactly sure about what that means, but you can definitely check with TechRandom. They can give you a better explanation than I can. I just don't want to give you wrong information. The next column after that is called area. That's just absorption units, or rather fluorescence units from the actual instrument. That's raw data from the fluorescence phenomenon. The column after that is nanograms per meters cubed, which you just informed me also corresponds to PPQ values. That is the emissions data. That's the raw data that we will use to calculate flux. And that is the TechRand output explained in a nutshell.